Here are a couple of questions I stole from the AP College Board website. They both have to deal with implicit differentiation. Please watch both of them because the first one is just regular find dy dx. The next one is going to find it at a certain point. They're very similar questions, but here we go. So this is just asking us to find dy dx. So we're going to use implicit differentiation. So remember, all the x's here are derived as normal. All the y's are chain rules. So the derivative of x cubed is 3x squared. That's easy. Plus. Now this is a product. Be very careful. People tend to forget or miss products when you're doing this. You can figure the 3 as a constant multiple, or you can lump it in with the x. I find students like, especially on these types of problems, to just carry it through with the x. So that's what I'm going to do. So it's like 3x times y. So the product rule says you take the first, 3x, times the derivative of the second. The derivative of y is not 1 because we're doing it with respect to x. The derivative of y is the derivative of y. So y prime. Plus the second, which is y, times the derivative of the first. The derivative of 3x is 3. Plus, now we have the derivative of 2y cubed. This is a chain rule. So the derivative of y cubed is 3y squared. That's the derivative of the outside. I left the y alone. Times the derivative of the inside, which is the derivative of y, just like we did over here. And then equals. Now, a lot of people forget this because we usually don't have two sides to a derivative, but for these implicits we do. So you have to take the derivative of 17, which is 0. So we have 3x squared plus 3xy prime plus 3y. So I'm just cleaning up, plus 6y squared y prime. Now, one thing you're going to notice here is that every single term is a multiple of 3. So you can divide everything by 3. That will save you some simplification at the end. So I did notice that, so I'm going to do that. If you wouldn't have done that, try to complete the problem without doing it. You'll see that at the end, you would have 3's factor out from the top and the bottom, and you would cancel them out anyhow. It's just easier to do it here. So the next step in implicit differentiation is keep all the y prime terms on one side. Usually it's the right because that's how things are set up, but that doesn't matter. Everything without a y prime, move to the other side. Factor out y prime from the side that has the y primes. The only reason why you would do that is because now it's easy to solve for y prime. You just divide this. Now, this is a multiple choice test. So if you don't immediately see your answer, which I don't, you're going to have to figure out which one it is. Well, you'll notice that all of these answers have a negative factored out, and that's what I would do anyhow. You don't usually want to leave it negative x squared minus y. So I'm going to factor a negative out from the top, x squared plus y over x plus 2y squared. Now, hopefully that's one of the answers, and it is. I was looking from the bottom up, and I was getting nervous I didn't see my answer. So it looks like it's A. So the next problem I wanted to show you, now this is, keep watching, because this is very similar, but you can approach it in a different way if you're doing the derivative at a point. I want to make sure you see that. It might be a little bit easier. So we have to find y prime at the point 1, comma 1. So we're going to start this problem exactly how we did the last one. It is very similar. So the derivative is derivative of x is 1 plus. This time I'm going to do it, I'm going to keep the 2 factored out just to show you with a different way. If the 2 is my constant multiple, I'm going to now, you still have to perform the product rule on xy. And so since I'm keeping 2 as a constant, make sure you write the product rule in parentheses. So the product rule for x times y is first times the derivative of the second. So the derivative of y is y prime, plus the second, which is y, times the derivative of x, which is 1. So I'm done with this one. And then minus, chain rule on this one. So 2y to the first times the derivative of the inside, which is the derivative of y. And this equals the derivative of 2, which is 0. Now, you can go through all the simplifications, solve for y prime, and then plug this in. But as I usually say, if you're dealing with numbers, there's no reason to simplify. A lot of times it's easier to deal with the numbers. This means plug in 1 for x and plug in 1 for y. So I'm going to do that right now. It's going to be easier. 1 plus 2 times x is 1, so y prime, plus y is 1, plus 1 times 1, minus 2 times 1 times y prime, 2y prime, equals 0. Now you just solve for y prime, because that's what you're asked to do. So 1 plus 2y prime plus 2, I distributed the 2. Combine like terms. 2y minus 2y is nothing. So I did not expect this to happen, I promise you that. But it can happen. The y primes cancel out, so I'm not getting an answer. So it's possible that it's non-existent. Now that's probably because it's on it's a vertical tangent line, undefined slope, but it definitely can happen. So there you go.